Alrighty, that is correct. Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Goo. We're starting Unit 11 today. Unit 11 is going to be less graphing, more arithmetic. So some of you guys would enjoy that more, some of you guys maybe not. But Unit 11, Notes 1. It is going to be solving exponential equations. Solving exponential equations. We're going to be doing a lot of solving this unit. All right. Real quick refreshment. Remember that exponential equation looks like this. There's a base raised to the x equals another number. All right. And we're going to be seeing how we can solve for x in this kind of situation with this kind of equation. All right. So I'm going to show you two methods today. We're going to need to know both of them because certain times one method is better, a lot faster than the other method. So method number one. I'm going to make two columns, by the way. Method one is going to be we take the logarithm of both sides and our example problem is going to be 7 raised to the x minus 4 equals 49. All right, so like I said, we're trying to solve, right? So what are we trying to get by itself here if we're solving for x? X, right, that's right. We're trying to get x by itself. Now look at here, though. Is x in the normal number spot right now, or is it somewhere else? Where is that x? Where is it? It's in the exponent spot, right? When we're solving for x, though, we don't want it in exponent spot, right? We want to bring it down, okay? And we've actually already learned this kind of concept before when we first learned about exponentials and logarithmics. So I want to bring the x down because it's exponent right now, right? But what's in the way of that? What's stopping me from doing that? Not the 4, the 7, right? Because the 7 is in the way. The x and the minus 4 are up there in the exponent spot. So I want to get rid of that base of 7. How do you get rid of a base? What? Log of what? Right, log base 7 would cancel out that base of 7. Remember, we've done this before. And you use this property on your test as well. So I'm going to take log base 7 of 7 to the x minus 4 on the left side. And because I put log base 7 on the left side, what do you think I have to do on the right side? Log base 7, that's right. So maybe this, somewhere in your mind, in the depths of your mind, seems familiar because we did this when we first learned exponential and logarithmic. Okay, so now right here on the left side, we have log base 7 of 7. What happens with that? Cancels. Boom. So now what's left? X minus 4, and it's not an exponent anymore, right? Now it's just in the normal numbers area. See how I wrote it a little bigger? So you can tell that it's not an exponent? Yep. All right, and now here's the part that I want you to get in your mind. Log base 7 of 49, right? That's a number, okay? This right here, log base 7 of 49, it's a number. It's just not clear what it is, but does anybody know what the number is? 2. It's 2, that's right. How did you get that? 7 squared equals 49. The 7 and the 49 are from what is written right there, right? The 2 is what it actually equals, though. So this 2, that's where the 2 came from. So we end up with x minus 4 equals 2. And how can I solve for x? Plus 4. So x equals? That is correct. And there it is. All right, let's take a look at method 2 then. So method 2. On method 2, we're going to rewrite so that both sides have the same base. And just to really show that this is the exact same answer that we get the first time, we're going to use the exact same example. 7 to the x minus 4 equals 49. All right, so let's make sure you read what it says, the method, and then kind of make some sense of it. It says to rewrite so that both sides have the same base. Now look at our equation right here, right? What base do we have? 7, right? So that's already a base of 7, so that one doesn't need to be rewritten. That we just keep that how it is. But 49, we're going to rewrite 49 so that it has a base of 7. But if I change 49 to have a base of 7, what exponent do I have to put on that 7? 2, right? Because 7 squared is 49, right? Now from here, take a look at what's even written there. It says that these two numbers, 7 to the x minus 4, is equal to 7 squared. It's the exact same number, right? The only way that these two numbers can be the same is if the x minus 4 up here equals what? 2, that's right. That x minus 4 should equal to 2 because these are the same number. So then we can just write that x minus 4 equals 2, and that will help me solve for x, right? That's the exact same thing we got last time. Look to the left right here. X minus 4 equals 2, and we end up at that exact same spot. And so now how do we solve for x? Add 4, so x equals 6. That's right. So same thing. Just two different ways to do it. Two different ways to approach it. Some people will like one way better than the other, but sometimes one way is better, faster than the other way. So that's all we're really learning for today, but we're going to do some examples just to get some more practice and see some different types of problems. So first example. Examples. Example number 1. It's going to be 4 to the x plus 1 equals 64. And you can use whatever method you want. So what method do you guys want to do on this one? The first one. Okay, so, all right, well, she already said the first one. We're doing the first one on this one. Okay, so if we're doing the first method, what should we do to both sides? Log base 4, right? So log base 4 of 4 to the x plus 1. And then what's on the right side? Log base 4 of 64. And then, yeah, the next step here, log base 4 of 4, what happens over here on the left side? Cancels out, so you're left with, right, x plus 1 equals, and what is log base 4 of 64? Not 5. 3, it's 3. Why is that? Because look, 4 raised to the third is 64. So yes, this is 3. Okay, and then how do I solve for x? So your answer is, right, x equals 2. Boom. All right. Let me erase this thing, it's in the way. Next example then. It's going to be 2 to the x minus 5 equals 16. All right, what method do you want to do this time? The second one. All right, so we're using the second method. What base do we have here? 2. So the left side is already with a base of 2. That's fine. So the right side, if we rewrite 16 with a base of 2, what's it going to be? 2 to the 4th. Right, 2 to the 4th. You have to use the same base. So the base is 2. The exponent will be 4. Because 2 times 2 times 2 times 2 is 16. All right. From that step, can you see what our equation is going to be to solve for x then? Whoa. Wait a second. X minus 5 equals 4, and then to solve for x at 5, so x equals? That's right. So actually, whenever you can use the second method, that one works a little faster, right? But you won't always be able to use that one. Sometimes you don't have perfect, bases.
So you can always use the first one?
The first one you can always use, yeah. But the second one, sometimes it's not going to work out very well. All right, third example, 2 to the 2x minus 3 equals 32. What method do you want to use? The first one, okay. If you're going to use the first method, what would you do to both sides? Log base 2, right. Equals, on the right side, we have log base 2 of 32. That's right. All right, so on the left side, the log base 2 of 2 to the 2x minus 3, that would cancel out. So what's left? Equals, and what is log base 2 of 32? 5, that's right, it is 5. Because 2 to the 5th equals 32. All right, so now we got to solve for x, so what should we do? Add 3. So we get 2x equals 8, and then what? By? And so x equals? That's correct. Nice. All right, we got 3 more examples. So, you still writing? Still writing? Okay. Example 4 then. This one is going to be 1 over 4, oh boy, equals 2 to the 2x minus 6. All right, so what method do you want to use on this one? The first one? All right, you want to use a log? Okay, so what log are you going to take on both sides? Right, log base 2. So log base 2 of 1 over 4 equals log base 2 of 2 to the 2x minus 6. So on the right side now, the log base 2 of 2 would cancel out, right? Which leaves you with. And what is log base 2 of 1/4? Negative 2. How'd you get that? Because you can think about it like this. You see the 1 over the 4, right? So look at the bottom number, it's 4. So how am I going to raise 2 to get to 4? It'd be 2, right? But the fact that it's on the bottom, it's a fraction, you put a negative sign in front. So negative 2. All right. Anyways, so how do we solve for x then? Right? So what are we left with after we add 6? And then? Which leaves you with? That's right. All right, so the last 2 examples we're going to look at are a little more complicated, but not that much. So example 5 is going to be 4 to the x plus 4 to the x plus 7 equals 2 to the x minus 1. Oh. Whoa. This one looks a little different. So when you see a problem like this, you probably want to use method 2, okay? Because if you use method 1, it's going to be a lot of extra steps that you're not going to see in method 2. All right, so let's say we're using method 2, right? But you see there's 2 bases here, right? One has a base of 4, one has a base of 2. But which base do you think would be easier to work with? 2, right. So we're going to use the base of 2. So 2x minus 1, right? Because on the right side, it already has a base of 2. We want to change the left side so that it also is using a base of 2. So that 4, how can I rewrite 4 with the base of 2? 2 squared, right? Because 2 squared is 4, right? However, look at your original, right? You see that 4 is being raised to the x plus 7, right? Which means that my 2 squared should also be raised to the x plus 7, right? Because my 2 squared is just my 4. So I got to make sure that I'm raising it to the same thing, x plus 7. And now from this step, oh, my eraser. From this step, does anybody remember what we can do with these exponents right here that are right next to each other? No. I was asking, what can you do with these exponents right here, based on the rules, based on the exponent rules? Here, let me ask you this then: if you have x cubed like this with a 2 here, this is the same as x what to the? How did you get that? What'd you do? You multiply. So what do you think you can do with these exponents over here? Multiply them. That's right. So, okay, my eraser's just not working. So if we're going to multiply, I have to distribute my 2 to both of these terms because we're multiplying. Right? And so now I have 2 raised to the what? 2x plus 14 equals, and my right side was 2 to the x minus 1. And now that we're at this step, you can write an equation to solve for x. So what would that equation be? That's right. 2x plus 14 equals x minus 1. And now we can just solve for x, right? So what would we do to solve for x here? Subtract 14. Ooh, whoops, spoiler. If I subtract 14 from both sides, what am I left with? Right, and then not divide the x. Subtract the x, right. And then what am I left with? That's right. X equals negative 15. Alright, so yeah, actually doing it with method 2 here does save you a couple of steps and makes it a little less complicated. So there it is. Let's do one last example like this just to get some more practice in, but our last example is going to be 2 raised to the x plus 12 equals 8 raised to the x plus 2. So does anybody know what we would do here?
It's the same thing as the last one.
So what do you do?
Put instead of putting the 2 to 2 squared, put 2 to the third.
Where?
Like where the 2 is.
This 2?
Yeah.
This one already has a base of 2, right? So we don't have to touch that. Yeah, the other one, the 8, that's not a base of 2. We're going to change the 8 to have a base of 2. And then as you said, what's the exponent going to be? Cubed, right, 3. Because 2 to the third power is 8, right? And what exponent do I need to put on the outside of that, though? X plus 2. Right, because the 8 is just 2 to the third. I need to make sure that I'm still raising it, though, to x plus 2. Now what do I do from here? Multiply what? Right. So we have 2 to the x plus 12 equals what? 2 to the? That's right, 2 to the 3x plus 6. And what would my next line say then? 2x plus 12? What about the first part here? What'd you say? Oh, x plus 12. I did not hear that. I did not hear the x. Okay, x plus 12 equals 3x plus 6. That's right. Okay, and then? Now we're just trying to solve for x, so what should we do? Subtract 6, right? We should subtract 6. So that's going to help us keep the x term positive, right? So if I subtract 6, what do I have? X plus 6, right? And then? So 6 equals 2x, and then? So then x equals? That is correct. X equals 3. Boom. There it is. All right, one note that you guys do need to make, though, watch this real quick, because you're going to see this for sure, is make a note of this somewhere. Let's say you get to a point, right, where you're working, and then you end up with this, like 3x plus 1 equals 3x minus 3, right? And what would you do? You subtract 3x from both sides, right? Minus 3x minus 3x. What would that do, though? So you have 1 equals? Okay, does that make sense, though? No, so that's right, you're right. So the answer here is no solution. So if you end up with something really weird, that doesn't make sense, then your answer is going to be no solution. Because all you're doing is telling what are the possible solutions of x so that these two things equal each other. There's no way to make these two equal each other. And that's going to end the notes. So, until next time, see ya then. Peace. See ya.